Hello class, my name is Connor and welcome to my presentation on aircraft component life cycles and their effects on maintenance scheduling. To start, it's important to understand why aircraft life cycle plays such a major role in maintenance scheduling. Aircraft and their components have limited lifespans, both structurally and economically. Maintenance schedules are designed to manage wear, fatigue, and aging throughout those life cycles. And as an aircraft moves through different stages, the inspection frequency and task scope must change to maintain safety and regulation compliance while also controlling long-term costs. Aircraft and their components follow predictable life cycle patterns, beginning with entry into service, moving through maturity, and eventually reaching an aging phase. Components experience wear, fatigue, corrosion, and obsolescence over time. Maintenance schedules are built around these degradation patterns, and as aircraft age, additional regulations begin to influence how inspections and maintenance tasks are scheduled. In the early life cycle stage, maintenance scheduling is relatively straightforward. Inspection intervals are longer, and maintenance primarily focus on routine scheduled tasks. Most components are operating well within acceptable limits, so corrective maintenance is minimal. During this phase, preventative maintenance dominates, and operators collect reliability and performance data that will later support adjustments to maintenance schedules as the aircraft ages. As aircraft enter the midlife phase, maintenance scheduling becomes more complex. Wear trends begin to appear, allowing operators to refine inspection intervals and expand the task scope. Structural and system inspections become more detailed, and regulation oversight increases. At this stage, aging aircraft requirements begin driving additional inspections, which increase planning effort, labor hours, and maintenance downtime. For aging aircraft, maintenance scheduling changes significantly. Inspections related to fatigue cracking and corrosion become a primary focus, and airworthiness limitations play a larger role. Heavy maintenance occurs more frequently and are much more expensive. Component replacement intervals also shorten due to wear and obsolescence, making scheduling less predictable and much more labor intensive. Individual components often have life cycles that are shorter than the aircraft itself. Life-limited parts require mandatory removal or overhaul at specific intervals, which directly drives maintenance schedules. Unconditioned components also require increased monitoring as they approach end of life. Airworthiness limitations establish required inspection and replacement intervals, which significantly affect task cards, labor planning, and material forecasting. As maintenance schedules become more demanding, operating costs increase. More frequent inspections raise labor hours and material usage, while heavy maintenance greatly affects the cost per flying hour. Aging components also contribute to higher rates of unscheduled maintenance. Overall, maintenance scheduling is one of the primary drivers of rising operating costs as an aircraft progress through their life cycle. There comes a point where maintenance scheduling itself signals that the aircraft replacement should be considered. Rising costs per flying hour, longer downtime, and increasing complex inspection requirements are key indicators. Major inspections such as D checks often trigger the keep versus replace evaluations. In some cases, regulation requirements make continued operation economically impractical. Maintenance scheduling data plays an important role in long-term fleet planning. Airlines must balance safety, regulation compliance, and cost efficiency. While effective maintenance programs can extend aircraft service life, there is a point where continued operation no longer makes sense financially. Lifecycle-based scheduling helps management determine when to invest in new aircraft and align maintenance strategies with the overall fleet planning. This concludes my presentation. Thank you very much for listening and have a great day.